Hey, so we are back with another new topic, microbial nutrition and metabolism, and that's also coming under the top 50 concept of GAT-B that we're covering, right? Okay, so what's the nutrition? As we know, for our survival or anything, uh, we need some protein, carb, and as well as fat, lot of vitamins and different minerals, right? So bacteria also need this, right? Because bacteria need to make protein for its own survival, as well as it need to divide as a living being, right? Right. So we can broadly divide the nutrient in two categories. One is the macronutrient, that is the carbon, hydrogen, nitrogen, oxygen, phosphorus and sulfur. Right, CHN, carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. So carbon means the major source of carbohydrate, or maybe like glucose, dextrose, anything. Hydrogen, it's of course there. Nitrogen, main source of protein. Oxygen, CHO, again the main source of carbohydrate, right? Phosphorus, main source of nucleic acid, followed by sulfur, that's the main thing of amino acid, as well as some redox mechanism as well. And if we talk about the micronutrient, that means those require in quite less quantity. That's a zinc. Uh, those are the cofactor for some enzyme, let's say alcohol dehydrogenase, nickel, ferrous, manganese, cobalt, right? So in some nitrifying bacteria, just for nitrogen fixation, they also need something, right? Uh, right. So microorganisms are broadly classified based on the few criteria in three categories. Let's say first one is the carbon source, which one it's using as a carbon source. Second one is the energy resource, and third one is the electron source. Right? I am repeating. First one is the carbon source. Second one is the energy source, and third one is the electron source. Right? Now we will go one by one classification, and this will be quite short class, so I want each of you just to pay attention, and because sometimes people ask questions from here and you will be able to answer if you just remember a few things. It's not that much difficult, right? So autotroph, that means the main source of the is the carbon dioxide, and fix inorganic carbon into organic compound, let's say from CO2 to 3-PGA, 3-phosphoglyceric acid, from there to C6H12O6, right? Some glucose or some other compound. Use Kelvin cycle or reverse TCA. Example, cyanobacteria, nitrosomonas and thiobacteria. Autotroph means they can make their own food. They are not dependent on anyone. They can fix their own food by fixing the CO2 from the atmosphere. Heterotroph, that means the carbon source is of course some organic compound. They will take from soil, maybe some soil organism, soil organic carbon, right? Depend on preformed organic carbon, right? Sorry, preformed organic carbon. That means whatever is present in the soil. Let's say some wooden plant or something, some leaves, right? Those are already there, so it can utilize those and it can fix their carbon. Example, that's the E. coli. If you see the LB media that we used in lab, right? So if whatever you use in lab condition, that's also the extra supplement. So E. coli is also dependent on some other supplement, whatever we are providing through the media. It's not making their own food, right? Some fungi is also there, some protozoa and some pathogenic bacteria is there. So remember, E. coli is a heterotrophic bacteria. It's not the autotroph. So it can't make their own food. That's why we need some LB media, right? Luria botany medium, right? LB media. And remember, cyanobacteria, nitrosomonas and thiobacillus, those are the example of autotroph. That means they can fix their own carbon dioxide, right? Okay. Next, classification based on the energy source. Energy source means what? It can be direct from the sunlight, or it can be from any chemical. That means either sunlight, that's a phototroph, or chemical, that's a chemotroph. When we are considering the phototroph, that means the energy source is light, and they use pigment like chlorophyll, bacteriophil, because this chlorophyll or other kind of pigment, they absorb some energy, and then this energy actually help in fixing the carbon. Let's say if you remember in plant uh, things, but there is jet scheme, right? So from jet scheme they got NADPH something, and these are utilized in C3 cycle. So this kind of way, so you are utilizing the plant electron, and then you are utilizing the solar energy, and from there you are helping in fixation of your food, right? The example is cyanobacteria, of course, the green sulfur, purple sulfur bacteria and green sulfur bacteria. So those are dependent on the sunlight to make their food, right? Next is a chemotroph. Chemotroph means, as the name suggests, the energy source is a chemical compound, and the oxidation reduction reaction supply actually the energy, right? The example is E. coli and the nitrifying bacteria, right? E. coli and nitrifying bacteria both comes under this category. So these two are the major classification based on the energy source, right? One is phototroph, one is chemotroph. Next, based on the electron donor, that means first one is the lithotroph. Lithotroph means electron donor or inorganic compound. Organotroph, that means they are getting electron from the organic compound, right? Lithotroph means, let's say there is some inorganic fertilizer, something from there they are getting, right? Let's say ammonium, nitrite, sulfide, ferrous. If these things happening, if they are getting electron from there, these bacteria are called lithotropic bacteria, like Nitrosomonas. They utilize NH3. Nitrobacter, they utilize nitrite and convert maybe to nitrate, right? And organotroph, or maybe the reverse one. Organotroph, that means they utilize the organic compound, right? Organic compound, and from there they collect the electron. Most example like bacteria, fungi, protozoa. So first thing is the carbon source. Carbon source, that means the autotroph, heterotroph. Autotroph means they can fix their own CO2, right? Hetero means they have to be dependent on other thing that's present, maybe in soil, organic carbon or something. Second thing comes based on the energy, that's direct sunlight, and another is the chemical, the chemotroph and phototroph. Next one is the based on the electron donor. One is the lithotroph, that means electron donor from inorganic compound, and organotroph, that means electron donor from the organic compound. Okay. Next, so bacteria, of course, the combination is also should be there, right? Let's say there is major, if you consider carbon, there are autotroph, heterotroph. If you consider energy, there is phototroph and there is chemotroph. If you consider electron, there is lithotroph and there is organotroph. Now you can make different combination as well. This is the autotroph and heterotroph, right? Let's say photoautotroph, PA, photoautotroph. That's they can synthesize the carbon dioxide with the help of direct energy from the sunlight, right? The biggest example is the cyanobacteria, right? Photoheterotroph means, that means they are utilizing sunlight, right? But they are taking the carbon from the soil. That's the organic portion. That's called photoheterotroph. So PA, PH, photoheterotroph. Okay. Chemoautotroph, that means they are utilizing the energy from chemicals compound, right? It can be any chemical compound, but they are making their own CO2, fixing their own CO2, right? That means chemoautotroph, chemoheterotroph, right? You have to just remember this table. If you remember this in systematic way, there is nothing, right? You can make different combination, and something that you need to remember, let's say purple non-sulfur bacteria. That means it, of course, those are dependent on light, but those can't fix their own CO2. This will be dependent on something. That's why they are photoheterotroph. Nitrosomonas, as the name suggests, it's connecting with the nitrate assimilation and all this thing, nitrifying bacteria. So it's directly dependent on the chemical thing, and it can synthesize their own CO2. That means chemo autotroph. Yeah. So here is few question for you. Let's say here you need to see which organism is there and then nutritional type. It says cyanobacteria, which one? Nitrobacter and E. coli. Right. See, first thing P2, right? So P2 is always correct. You have to see P2. Cyanobacteria, cyanobacteria. That means P2 is always correct. You can remove these two options. Followed by E. coli is the chemo heterotroph and E. coli is the chemolithotroph. Of course, E. coli is the chemo heterotroph, right? That we already observed, right? That E. coli under the category of heterotroph, and also it utilizes the chemical energy. That means E. coli 1. That means Q1, right? And R, Nitrobacter, that is the chemo and litho. That means it's getting from the inorganic compound. That's why the option A will be correct one. Okay. Which one of the following statement is correct? All lithotrophs are autotroph. All autotrophs are lithotrophs. Lithotroph use inorganic electron donor. Organotroph cannot be autotroph. It's quite easy question. Just read it carefully. Which one of the following is correct? First one, all lithotrophs are autotroph. No, there should not be any hard and fast rule. All autotroph are lithotroph. No, autotroph can be let's say organotroph or something, right? Lithotrophs use inorganic electron donor. Yeah, that's true. They are from inorganic donor, ID, inorganic donor. Organotroph cannot be autotroph. That's also wrong. That means the correct option is the C. So question number 2, the correct option is C. So here you need to remember a lot of things actually. An organism use CO2 as a carbon source, right? CO2 as a carbon source. That means, of course, it's the autotroph. H2S as an electron donor and light as an energy source. Light as an energy source, that means, of course, it's a photo. And this is the litho, right? So it is an photo heterotroph, chemo autotroph, photo autotroph, chemo heterotroph. Of course, photo and auto, these things are matching, right? That is photo autotroph. The correct option will be C, photo autotroph. So here the H2S thing is actually you should not consider. Consider means the combination here is not there. But as of now you can think H2S, that means it's a lithotroph, right? And you can make some combination, and that's the photo autotroph. Next. Purple non-sulfur bacteria are described as photo autotroph, photo heterotroph, chemo autotroph, chemo heterotroph. Purple non-sulfur bacteria. Of course, they utilize photon from light, sunlight, and they are dependent on someone. That means this is the photo heterotroph. So option B will be correct. You just make one chart and you have to memorize it. There is no other option. Anyway, if you read it more and more, at that time you will recall all these things. Right. Okay, so that's all about today, and next day we will also consider some another new topic. Right. Till then, bye bye.